Hi again! Welcome to Lesson 9 on Designing Database Solutions with Microsoft SQL Server 2022. For today's topic, we will discuss SQL Views. You'll understand why it plays an important role in designing your database systems. You'll learn how to create, alter, and drop SQL views. You'll understand the purpose of schema binding. And finally, you'll learn how updatable views work. So, what is an SQL view? A view can be thought of as either a virtual table or a stored query. Virtual means that the data accessible through a view is not stored in the database as a distinct object, but only as a select statement. To explain this further, I will be working with this view demo database, and in it, I have created three related tables for us to work with: the employees table, departments table, and attendance records table. The employees table has some common fields such as employee ID, last name, first name, middle name, birthday, email address, the hourly rate, which is of type small money, and finally, the department field, which is a foreign key in a many-to-one relationship from the departments table. Here, we have the department ID as the primary key, the department's name, and its contact number. Finally, we have the attendance records table, wherein one employee can have one or more attendance records. And just for demo purposes, let's keep it simple. Suppose we just need the attendance date and how many hours our employees have rendered on each recorded date. I've already entered some records into these three tables. And as you can see, the employees table consists of 5 employees, and here are the rates per hour, as well as the department to which they belong. For example, Kent, Wayne, and Parker belong to the Information Systems Department, and Tony Stark is in Human Resource Office. Now, in the attendance records table, we also have some logs here. Say, employee 2001, which is Clark Kent, rendered 8 hours last January 3, 2023. Then on January 4, he rendered 9 hours. And again, on January 5, he made 8 hours. So you get the idea that this table stores lots of records for all the employees' attendance daily. Now, having multiple tables that are related to one another, we typically retrieve records to these tables using either SQL join or subquery. So, I'll create a simple query joining the attendance records table and the employees table. Of course, if you're going to create some kind of report, you might want to select only the appropriate fields. And I'll just get the employee ID, the formatted employee name, the hourly rate, the hours rendered, and the attendance date. So now, we have a result set that is much simpler to look at. We can simplify this further by aggregating the total hours rendered by each employee like this. I'll remove the date field, and then add all the individual hours rendered per employee. Of course, when we use an aggregate function like sum, average, count, etc., we must use the group by clause to specify the column names that must be displayed along with the aggregate functions. And now, we have a summary of all the individual employees' total hours rendered. Depending on what we want with our report, for example, we can even hide the hourly rate and the total hours field by doing a simple computation to display only the product of these two as the salary for January 2023. Of course, to filter this as a January 2023 salary, we need to include a where clause to specify our condition. Now, our result set only shows a super simplified outlook of these two tables, In fact, this looks like a totally different table. So, what now? How is this related to SQL View? As I mentioned earlier, View can be thought of as either a virtual table or a stored query. And if we have a query like this wherein users of our database system need to include it in their application or report of some kind, such as the human resource or the payroll department, then we can create an SQL view out of this. To create a view, simply type create view and then the name of your view. I'll call it View January 2023 Salary, and the name I gave is very descriptive. Now, followed by the ask keyword, and then your select statement like this. And that's it. I'll click execute, and under the views folder, right click and then refresh, you'll see your newly created view. And now, any authorized users of this view can simply reference it in their transact SQL statement the same way a table is referenced. Of course, we get the same result. So, just like selecting through any table, you can specify what fields to include. Please do note that the data accessible through a view is not stored in the database as a distinct object, but only as a select statement. Here, the tables referenced by the select statement are known as the base tables for the view. There are several benefits of using a view. The most credible benefit of view is simplicity. It reduces the apparent complexity of queries and prevents redundant hosting of data in your database. Just like in our example, we could create a view for a complex query that pulls data from multiple base tables. I'll modify this view by using the alter keyword instead of create, and then I'll include the hourly rate and the total hours rendered as separate fields. And then join this to the departments table so that I can include the department name. I'll execute this code. And now, this query selects a fair amount of information for the users to consume, but underneath, the users of this view don't see the actual table structure or how many base tables are involved. Views are good for encapsulation and abstraction. It hides the apparent complexities and at the same time it offers an additional layer of security. Database administrators can allow users of the database to access only selected objects such as views and then restricts selected users from accessing the base tables directly. In this way, it reduces the risk of exposing unnecessary information to some users and it gives better control for the database administrators. Now, if I were the programmer creating an app or a report that uses this view, I still have the flexibility to create my own query on to what fields to include, but at the same time, not so much authority since I am only limited to what the view is allowing me to select. You can have as many views as you want depending on your needs. Suppose that in this organization, the Information Systems Department wants to have a view of the attendance summary of the employee under them. So, instead of giving a full access to the attendance records table, wherein all employees' logs are included, we could create a view that limits the viewable records or rows only to the Information Systems Department employees. Now, I'll include only the hours rendered and the attendance date, and then add a where clause to filter records only to the Information Systems Department employees. I'll execute this, and now we have a virtual table that holds only the Information Systems employees' attendance summary. Just like with any table, we can still create queries referencing this view that include aggregate function like this. When creating a view, it doesn't have to be always due to complex join statement. Sometimes, the reason is that you just want to protect some fields and don't want to expose your table structure to some users that need access to your table. Like in this employees table, you can create a view to hide sensitive information to some users of your database. For example, this view only allows user to access employee ID, first name, middle name, last name, and email address. It is not necessary to include the birthday and the hourly rate if we are just creating, let's say, a mailing list. In addition, view is also good for consistency and maintainability. Consider a scenario wherein different users or applications are accessing your database. Now, with views, each user or app doesn't have to write their own versions of the query, especially if it involves complex joins with computations, as it might lead to inconsistency of the query results. In addition, if comes a time that the tables of your database need to be restructured or upgraded for whatever reason, this could be a huge problem if all your users or apps are directly accessing your database tables, because they have to rewrite a new query to match the new table structure. But when using a view, you don't have to worry about that. Your application will still run just fine since your query is transacting to a view, even if the base tables have changed, so long as your view keeps its structure the same and update its query to reference the new base tables, then you're good to go. You just have to update the view instead of the different app connected to the database. When creating a view, consider the use of schema binding. This prevents your view from being orphaned when the base tables change their definitions, whether accidental or intentional. And to illustrate this, I'll go to the table definition of my employees table and change the email address field to simply email add. I'll save it. And now, as expected, selecting to a view that references an email address field that no longer exists in the base table will cause an error. Specifically, it is a binding error. To avoid this kind of unwanted error in the future wherein users selecting through views will break once the base tables change their definition or are no longer available, you must use schema binding. So, I'll change this back to email address first. Of course, our view works the same as before. Now, I'll modify this view and include this with schema binding keyword. And then I'll execute this code and notice that an error message occurred saying the name employee is invalid for schema binding and names must be in two-part format. This error can easily be avoided by making sure that when using the schema binding option in creating a view, all reference tables and views must use the two-part naming convention, as in schema.object. So I'll modify this query to include the DBO schema. DBO is the default schema in SQL Server, and we'll talk about more of these in some later videos. And now, when I execute this, it works, and the result set is still the same. So now, let's see how schema binding works. I'll modify this email address field again and change it to email add. And the moment I save it, I instantly get these violation warnings, and it informs me that this employees table is schema bound, and if I continue to modify it, the schema binding will be removed. And this is good. So I'm not going to continue with the change and use the email address fields instead. Views in all versions of SQL Server are updatable. It can be the target of update, delete, or insert statements as long as the modification affects only one of the base tables referenced by the view. For example, I can use the insert statement to insert to the employees base table through this view employees. Now, the employee ID field is set to auto-increment by 1, so I don't have to supply this value in my query. However, the fields that I need to supply the values are the last name, first name, middle name, and email address. So I'll provide the following values. And then when I execute this, it gives me an error saying column does not allow null. Note that the records remain the same as the insert statement was not successful. The reason is that if we take a look at the employees table design, the birthday, hourly rate, and department fields are not part of the view employee, and yet these are required fields. So the solution is that either include these fields in the view or put a default value in these fields. With that, I'll simply put a default value for birthday, for example, January 1, 1900, an hourly rate of, let's say, 100, and department of 1. I'll save it, and when I execute this code, notice that we were able to successfully insert new record through this view employees. The record was inserted to the employees base table through this view. Similarly, we can update record through views. I'll change the first name to John of this employee ID 2007, and then I'll hit execute, and we were able to update the employee's name from Joed to John. Now, there is another optional clause that you can use in Updatable Views, the with check option clause. Consider this example. I'll create a new view of employees using Gmail, so I'll filter it to only employees where email address has a gmail.com at the end. Now, let's see the result set of the view employees using Gmail and all the employees. And we only have 3 employees using Gmail account. Now, since views are updatable, imagine if one user of the view tries to update the email address field through this view, and then change it to non-Gmail address. What do you think is going to happen? Say, I'll set the email address to johngo@yahoo.com for employee ID 2007. And now, when I execute this, notice that employee 2007 was removed from the view since its email address is no longer Gmail. If you don't want this kind of behavior, you can use the optional with check option. With this, insert and update operations that make the record disappear from the view result set raises a trappable runtime error. To test it, once again, I'll change the email address to super@yahoo.com for, let's say, employee ID 2001. And when I execute this, the update failed because the target view specifies the with check option. Thus, the records remain the same. And that's it. You're able to create and understand how views work in SQL Server. Up next, you'll learn how to work with user-defined functions in SQL Server. To help this channel, please click the like and subscribe button for more video lectures just like this. Again, thank you very much for watching. This is Joed Go and hope to see you again in our next lesson.